I got my couple saws, my training saws, kind of cleaned up to head out this week for a training project up in Connecticut. And I thought I might take a few minutes here in the shop and talk a little bit about sharpening, because I get a lot of questions, and there's a lot of different concepts out there as far as chain types and bar lengths and all this kind of thing. But you know, I found over the years that the most important thing is a sharp chain. And so a couple different things that I rely on is going back to the basics, looking at the design of the tooth, and then also taking a look at some different tools. All these tools that I have here, I mean, they basically all do the same job. Some of them a little bit faster than others, but they all do the same job. They try to put that chainsaw tooth right back to how it came out of the box. And one of the things I always say is sharpening is kind of an art. But the other thing is that you're probably going to be doing more repair of the chain tooth than you are sharpening it at most cutting situations. Because what really causes the cutting capacity, the speed to go down, is usually damage to the tooth. So we'll go through a little bit about the types of teeth at some point, but more or less I'm just going to look at evaluating the chain from a standpoint of damage, and then how do we correct it. I like to take and just go over 5 parts of the design of the tooth, and we always go over in the training because it helps us to be able to understand what parts do what on the tooth, and then we can be able to better maintain them with the files or the grinders. So the first one is out here in the front. This is called the depth gauge. Some people call it a raker, some people call it a drag, but technically it's a depth gauge. The height of this sets up how thick the chip is that's going to come off of this tooth in the cutting process. And usually they're about 25 thousandths of an inch below the second part, which is the point or the working corner. This part is really what takes the brunt of the abuse in most cutting situations. That's the first part that starts to really dull. And this should be very sharp with no damage on it. And that's two things: the depth gauge and the point. They can cause the tooth to start pulling to one side or the other, or to resist the fiber, which causes the entire chain loop to pull towards its more sharper side. And so you end up with what I call a rocking chair cut, a left or a right as you go into the wood, and can sometimes even stall the chain down in the cutting process. So the depth gauge and the point. The third is the side plate of the tooth, and that's a measurement that more or less is a visual of 90 degrees. If we were to take here and look from the point to where the file would rest on this side plate, it's a concave setting on a round file chain, but it is a vertical visual of 90 degrees or perpendicular to the bar. And what that does is that keeps the angles correct as the tooth starts feeding in. When the front hits up here at the depth gauge, it goes forward, then the point bites in, then it rocks back, and it starts to pull itself through the wood, taking out that 25 thousandths chip thickness. So that's an important one. And usually most of your cutting takes place up here in this upper section of the side plate. So you want to make sure that no damage there and the proper visual. Alternative to that would be, and we see this quite often in the field, we'll probably look at it a little bit on the chains here in a moment, but if that point is farther forward, it's called a hook. And that hook is not going to clear the chip out properly. Sometimes people think it's a little bit more aggressive, and it can be, but it's something where it really doesn't cut to the chain tooth capacity when you have a hook. The other alternative is a back slope, and we see that a lot on smaller saws or pole saws, where somebody tries to use too big of a diameter file and basically puts the point back behind the side cutting surface. And so those are a couple situations we see quite often with the side plate. The fourth one is up on top. That's the top plate angle. And usually there's a witness mark there to kind of show you what that particular chainsaw tooth design should be sharpened at. That's also a witness mark that tells you that when you sharpen back to this point, you probably don't have enough metal to sustain the cutting. So you want to make sure that you replace your chain at that point. So there's two factors on that witness mark, but one of the biggest until you get back to that is looking at the top angle of the tooth. Most of the time, a semi-chisel tooth will be a 30-degree top angle. Full chisel is generally thought of to be a 25. If you get into a square ground, full chisel, square filed, you're looking at about 20 degrees on the top plate. The big advantage of a full chisel chain is that you can reduce the width of the kerf, and that's what this top angle does. It more or less opens up the width of the kerf that the chain is making in the wood. So that's an important angle, and you don't want any damage up here in this area. And then the fifth is the chisel angle. And this chisel angle, it kind of looks like a front end of a flat chisel. We generally say it's about 45 degrees, but in reality it's probably more in the 50 to 55. But it's something that more or less like a front end of a flat chisel, it peels the chip out between the two verticals. So that's the 5 parts of the chain: the depth gauge, the point, the side plate, a visual of 90, the top plate, 25 to 30 degrees, and then the chisel angle, which sets up at roughly a 45-degree angle. The cutter works kind of like a flat chiseling process, and maybe this can illustrate just a little bit here. One thing is that if this were a flat chisel, it would have a beveled edge, roughly 45 degrees. You have a point on this side, point on this side. You could even set the depth to, quarter inch or whatever. If we were to take the point here, and we drive this in, we would do that all the way down this particular area. Okay. Then we're going to turn the chisel over, and we're going to go down this side. And so what we're doing there, we're creating the two verticals. So that's kind of like the side cutter, the point going in and then the side cutter going down. Then we're going to take and turn that chisel upright, and we're going to chisel out between the two verticals. And that's basically what the left and the right cutter does in the sawing process, as that chain is pulled around the bar. So the depth is important. The side angles has to really do the toughest work, and then the depth gauge holds it to a certain depth to take out the correct thickness of chip without too much resistance, and then basically the chisel angle peels it out between the two verticals, left and right. So we'll take a look at this, what I've got in my little bench filing holder. You can see this particular chain has some wear back on it, some use time on it, and if we look here straight down, really start to look at the teeth themselves. So that the top angles on the right side of the cutter are pretty well matching the witness mark as far as the top plate angle. But on the left side, we have the point seems to be a little bit flattened back, and the angle seems to be, top angle seems to be a little bit curved and off compared to the witness mark. So we need to try to correct those. We want to try to have the proper size file for our tooth. This is a full profile 3/8 and full chisel. It calls for a 7/32 file. Now, you could possibly use a little bit different diameter, but when you start to look technically about 1/5 of the radius or diameter cross section of the file should be above that top plate if it's in the proper position. At this point here, I've got a 7/32. When I file through, I'm going to make straight strokes inside to outside, and I'm going to watch my top angles to make sure that I'm touching the entire surface, and I'm trying to follow that witness mark with that straight stroke. Now, when we start to look at a 3/16, then it's basically the same strokes through, but we want to make sure that we think about, we have to not go below that tooth top. So once we have the proper size file to get that total surface touched, then we want to make sure that we're taking off all the damage. And I do have damage on the other side, but I'm going to take and just make some damage here. And if we start to look at this, our file doesn't touch that area. So to be able to get the proper top angle with no damage, we've got to take that top plate back slightly. And so what I do is I take a good sharp flat file, and more or less I can make strokes through. I'm taking the damage off of that top plate. I'm realigning the witness mark with the top plate angle, and I've taken now that real hard surface of chrome. When you look, the tooth itself, the chrome surface is really the cutting surface. Under here is hardened also, but that chrome is really, really hard. If you have any abrasion or it's rounded over or there's damage back here in the point area, it's not going to cut correctly. So you want to make sure that you take and reestablish that.